So, what is mean by coordinate space? In the previous video, we have learned that in order to develop a complex geometry in software designing, you need to set your initial point, that is also known as a reference point. This is very much important. Either you are working for a 2D model construction or either you are working for a 3D model development. In both cases, the reference point play a very important role because in order to locate points for line, plane, or any other geometric form, their position, especially the initial position, must be referenced to some known position that is, as I mentioned, known as a reference point, or some says it is origin point. After that step, whatever you do or whatever geometric construction you made, you work using that reference point. And this basically, this setup, this phenomena is known as coordinate system. Now we have multiple coordinate systems according to the construction or the type of model you are going to develop. For now, we are talking about one of those coordinate systems among a few is a Cartesian coordinate system. In Cartesian coordinate system, you have both 2D and 3D space to locate your positions. So, what happens basically in the case of 2D coordinate system, let me show you this thing. 2D Cartesian coordinate system. This is a kind of a setup, that for when you work in a 2D space, you have only two axes, x-axis and y-axis, because any of the two axes is useful to make a plane. And when you are talking about 2D construction, it means you are working on a single plane, like a slice of paper. So, for a plane is basically developed with the help of two axes. Similarly, when you work in 3D workspace, there will be three axes in order to develop a multiple planes, right? So for now, we are talking about 2D planes. So there would be only two axes that could be x and y plane, x and y axes that will make xy plane. If you have, let's say, xz axis, they will make xz plane. If you have yz axis, that will make yz plane. So, first of all, if you take or you are basically even in coordinate system, you have two types of coordinate system: the world coordinate system and user coordinate system. For now, when we are talking about Cartesian system in a generalized way, ultimately we are talking about a world coordinate system, that is WCS in short form. So world coordinate system always begins with 0, 0 point. Where you do have a 0, 0 point, it's exactly the meeting point of those two axes. For instance, we are talking about x and y axis. So that world coordinate system, according to that world coordinate system, the origin, the reference point will always be 0 comma 0 point. Means you are beginning your drawing right here from 0 comma 0. So afterwards, if you want to take positive values, so for positive values on x-axis, there will be right side movement. The distance covered will be towards on the right side. If the distance will be covered towards left side after the origin point, the values will be in negative. Similarly, if you go upward from the origin, the values will be positive in another axis. Once you go downward in that same axis, the values will be negative. So towards left and downward, the values will be negative. And in the next picture, you can see the distance covered in x-axis is 3, and once you cover the distance in positive y-axis to 5, you will have a meeting point of 3 comma 5. And likewise, if you go downward on y-axis and remain same on x-axis, means you have covered distance in positive direction on x-axis, however in negative direction on y-axis, so it will become 3 comma minus 5. And likewise, if you cover distance on towards left from the origin point by 3, it will be taken as minus 3 on that axis. And if you go upward, the distance will be positive, whereas if you go downward, the distance will be taken as negative. So this 3 and 5, you can see on your screen, this 3 and 5 are basically distance from the origin point that we known as the reference point. So 2D coordinate system establishes an origin at the intersection of two mutually perpendicular axes. The origin is assigned the coordinate values of 0, comma 0. Values to the right of the origin are considered positive and towards left will be negative. Similarly, values above the origin are taken as positive, whereas below the origin, these are taken as negative. So using this convention, you can locate any point in 2D space by assigning a unique set of numbers to that point. The numbers assigned to each point are called coordinate points, where the first number is always denoted as or always taken as x coordinate and the second number as y coordinate. If you do not have x and y plane, and rather you have, let's say, x and z plane, the first number will always denote x coordinate, whereas the second will always denote the y coordinate. So, this is all about the 2D coordinate system. Now, how about the 3D coordinate system? In 3D coordinate system, third axis is introduced in similar perpendicular way to previous two axes. As you can see in figure 3.4, you have x-axis, you have y-axis, and those two axes were making a single plane. However, after introducing the third axis, which is perpendicular to the previous two axes, this axis will basically introduce a third plane, and that third plane will eventually make this setup to make a 3D model. Because once you will cover the distance in all three axes at the same point, eventually your model will be in 3D. So in a 3D coordinate system, the origin is established at a point where three mutually perpendicular axes meet. The origin is assigned the coordinate values of 0, 0, and 0. Third 0 is introduced over here. By convention, values to the right of the origin are taken as positive, like this, towards upward are also taken as positive, whereas the values coming out of your screen, the axis coming out of your screen will taken as positive, and the values or the axis direction that is pointing away from your screen are taken as negative z-axis. So the values in front of the origin are taken as positive, and the values behind the origin are taken as negative. So using this convention, you can assign a unique triplet of ordered numbers to any point in 3D space. The first number represents x distance, the second number denotes the y distance, whereas the third number indicates the distance by convention. So here you have an example of a rectangular prism in figure 3.5. If you see that after locating 3 points using each axis, you do have a distance in space, or I would say in 3D space. This coordinate system is used in multi-view drawings and 3D modeling using both traditional tools and CAD softwares. So you have 3.6 figure to know how the multi-view drawings looks like. Here is an example of a multi-view drawing. This is the 3D CAD model, and these are the 2D model development or the multi-view drawing or the orthographic views of this 3D view. If you can observe or see this 3D view from upside down, you do have this top viewport. If you wanted to see it from front side, you will have this 2D kind of view. As you can see, once you visualize 3D object from front side, you will have X and Y plane, which is denoted here, whereas Y is not showing with any line. Similarly, observing the model from top view, you will have X and Z plane. You see, once you come up with the model and wanted to observe it from the right side, you do have an Y and Z plane. And this sort of view. So I hope this is clear to you that how this coordinate space, coordinate system, and world coordinate system work in case of both 2D and 3D model development.